Hello everyone, welcome to 3.4 soil analysis. So to start with then, how do we collect our soil sample? So as you will hopefully remember from going to Bicton Common, our first method is using a soil auger. Okay, now this is great because it gives us a known cross section and depth of soil. So it makes it easier to standardize and make sure it's representative. The alternative is to use a trowel, which is less reliable. Not because it's less reliable to extract soil from the ground, it's probably more reliable, but it's less reliable to compare samples. Okay, so this is sort of our soil sample size from our big six coming in. Okay, so just to remind you, an earth auger is a cylinder of a known cross section, so a known diameter here, and it'll have a handle or something like that at the top to help you push it into the soil, and a trowel obviously is just a little tiny spade thing there. Soil temperature then is our next one we're going to look at. If you are using a soil thermometer, so use a thermometer, you need to put it to a standard depth. So typically something like 10 centimeters, unless you want to get temperatures at different depths. You need to avoid direct sunlight, which would interfere with your results. And you wait with it in the soil until you have a constant temperature. So just leave it there until it settles, basically. And you read the temperature while it's in the soil. So don't remove it from the soil while you're waiting to take your, while you're trying to read it, because that will affect your results. Okay. The next one then is soil water content. Okay, so this takes advantage of the fact that when we raise the temperature of a sample, water will evaporate. Okay, so if this is our soil sample, what you'll find, so these are my particles of soil in my soil sample. Water will be between the soil particles, sort of adhering to the outside of it through cohesion, and it might also be absorbed into some of the organic matter in some of the particles. Okay, if I want to find out what the water content is of a soil sample, I need to first off keep the sample cool and in a dark place. Okay, so like a fridge is perfect. And this is to prevent things like plants from growing and using some of the water up, or from the water evaporating. So it needs to be in a sealed bag. So a Ziploc bag is ideal. When you take it to work out soil water content, you remove large stones or organic matter like sticks or leaves or something like that. And then you place it in a pre-weighed basin, like an evaporating basin. Okay. You then need to weigh it. while it's still wet, you then heat it for 24 hours at 100 degrees C. Don't want to do any higher, that's fine. And what you will find is if we introduce it into an area of 100 degrees centigrade in an oven for 24 hours, all this water will evaporate off. Even the stuff that's being held quite tightly because it's absorbed into our soil particles. And we end up with a dry sample. Okay, so now we have all our organic matter and all our minerals and all those sort of things, all the dissolved stuff, all left behind, no water, so we have our dry sample. We then need to reweigh. Okay, you need to keep going, so it might take more than 24 hours. You keep repeating this process until, so repeat until you have a constant temperature. Okay, so it's not decreasing anymore. At least two masses remain the same, and then you know all the water's been driven off. And if you want to calculate the percentage water content, what you need to do is you have your wet soil mass, you take away the dry soil mass, divide that by our starting wet soil mass, and then multiply the answer by 100, and that will give you a percentage. Okay, so for example, if I started off with a starting soil mass of 100 grams, and then a dry soil mass of 50 grams, then I divide that by 100, which is our starting mass, so and then multiply it by 100 to give us a percentage. So that 100 minus 50 gives us 50 grams, divided by 100 equals 0.5, times it by 100, and that gives us 50% soil moisture. Nice and easy. Okay. And we follow a very similar process for soil organic matter. So you have to drive off all the moisture first. So do above first. Okay. And then when you've got your dry soil mass, you heat in a Bunsen or oven at a much higher temperatures. So it needs to be between about 200 degrees C and 550 degrees C. So it needs to be really hot. Okay. But this is really important. It's not too hot, because above 550 degrees C, you have carbon containing rocks will thermally decompose. So things like limestone will produce CO2, and we actually want to weigh the limestone and not lose any of its mass of CO2. So it needs to be slightly lower than that. Okay, you need to keep heating it and reweighing it until we have a constant mass that is reached. And then, like our example above for percentage water content, if we want to have the percentage organic content, we are going to have our dry soil mass, take away the burnt soil mass, divide it by our starting out dry soil mass, and then to get a percentage times by 100. Okay, and that will tell us how much organic matter makes up that soil. Okay.